All right, yeah. So for our turret, what we did was we took two Axon minis, and then we have a compound gearbox with with a gearing for 1-to-1. And then what we have is we have gears, and then we also have like a 3D print, and there's a bearing on the main turret plate which supports the servo spline. That way we don't have to worry about it possibly bending or breaking. And then we have that belted to our main turret, which lets it spin back and forth. And then we have an encoder to do continuous rotation on the axons. And I guess, Brett, if you want to talk about the wiring mechanism.
Yeah, sure. Okay, so for the wiring on this turret, we wanted to make sure we had as much range as possible so we didn't have to worry about limits while driving or wraparound. So we came up with a whole cable chain mechanism for our V2 here. You can see our chain wraps all around the turret. And the way this works is our chain is able to wrap and switch between these inner and outer loops here. So there's a section over here where it pivots between them, and the chain is just able to roll, giving us a whole 643 degrees of rotation. Then for the cable chain, we were able to design a print-in-place cable chain we were able to use to hold all the wires, and we made sure to buy flexible wires, and we ensured that the bend radius would be fine for the curve here. Then further for auto aim, we wanted to get hood adjustment so that we could shoot the same arc wherever we were on the field. To do this, we just used some helix gears on the back here with axon servos to allow us to raise and lower the hood. And we mounted the hood on bearings separate but concentric to our flywheel shaft to help reduce friction while still allowing for good rotation.
So our shooter, one of our goals was to maximize the amount of efficiency we had. So what we did was we used bare motors. We have heat sinks at the back, which keep the motors cool during the matches. And then we have GT2 belting, which powers the main shaft, which has just the flywheel on it. These are 3-inch anti-mark wheels. They're the green wheels, so that's the durometer. And then we have, GT2 pulleys, and we also replaced the bearings at which the main shaft are on. And so all the bearings we use are much higher quality than Gobilla's normal bearings. And so that basically lets us get a ton of spin, and it decreases our friction by a lot. For the hood design, I'd say like the main thing is just testing your compression. We certainly have gotten far zone shooting mostly consistent with just a normal hood and no back roller. We have tested back roller before, but we decided to pivot off of that because our back roller grip was inconsistent and sometimes it wouldn't make all of its shots. We have these guides here, which basically whenever the hood is up, it makes so that the balls don't just go flying out. We also tuned the compression on these guides, so we ended up reprinting these multiple times, and same with the back hood. We just used normal print here, so no grip tape or nothing there.
Yeah, and then also for the pivoting of the shooter, we made a bearing stack that we could have a custom sized hole while still having very low friction for turning. To make the bearing stack, we just stacked some bearings from Gobilla. We have, what are the names of them?
We have a thrust bearing, a radial bearing, and another thrust bearing at the bottom. We took the thrust bearings and then we added spacers inside of those and got them to length. You don't have to cut them down to be exact. You could definitely use 4mm spacers. Just make sure they're not threaded. There's just three levels to the bearing stack. So thrust, radial, thrust.